Okay, I'm going to go about showing you how I solve an 8x8 Ken puzzle, and I will fill in a couple of notes in some of these boxes for things that I'm certain about, like in this subtraction problem here where the answer is 7. I know that that's a 1 and an 8. To get 28 in a multiplication problem with 2 squares can only be gotten by 4 times 7. So I'll fill those in and get right back to you and explain what I've done. Okay, we are back, and I've put notes in where I know certain numbers belong in boxes, but I don't know the order yet. 4 times 7 is 28. 1 and 8, 8 minus 1 is 7. Same thing down here. 1 plus 2 equals 3. 4 times 5 times 8 will get us the 160. Again, I don't know the order yet. This one was particularly interesting. 525. Whenever you see it end in a 25, 50, 75, or double zero, that means there are 2 5s in that particular multiplication problem. So if I just put the first 5 into it, 5 into 125, or 525, I'm left with 105. And if I put the second 5 into that 105, I'm left with 21, which is 3 times 7. So one of the rows will both have a 5 in it. One will be 3, 5, and 7. One will be 1 and 5. And the reason why I know the 1 and 5 go up here is because the 1 and 2 are already here. So 1 and 5 there, 3, 5, 7 there. Now, moving on. Looking at the rightmost column, I see a lot of division problems, a division problem here and a multiplication problem here. They can't use the number 5. Since 4 and 7 are already occupying these boxes, 5 has to go into one of these two in this subtraction problem. That 5 in that row means that this is a 5 here. This answer of 1 can only be gotten by 5 minus 4 or 6 minus 5. We already have a 4, so that becomes a 6. Continuing in this column, the 2 division problem can be gotten by 1 and 2, 2 and 4, 4 and 8, or 3 and 6. Because there's a 4 and a 6 in this row already, this can only be gotten by 1 and 2. Can't be gotten by 2 and 4. There's already a 4 there. 4 and 8, obviously, same problem. Or 3 and 6. So this has to be a 1 and a 2 right here. I'll put those in. Okay, now with the 1 and the 2 in, we are left with 3 and 8 to finish out that column. With this 3 in that particular row, that means this must be an 8. 3 goes here. Let's add a couple more numbers. 192 divided by 8 gives us 24. Divided by 3 more leaves us with 8. That can only be achieved by 1 times 8 or 2 times 4. We already have a 1 and an 8 in this row, so that means this must be a 2 and a 4. I'll make notes. Okay, now to finish out this row, we are left with 5, 6, and 7. 5 plus 6 plus 7, we don't know what order just yet. However, we do know that equals 18. From the 22 means that we have a 4 here. To finish out this particular row, we only have one box left. That'll be a 6. Let's go here to the 1 and the 8. Because the 1 and 5 go in this row, that 1 is canceled out. That makes that an 8. This is a 1. Now, finishing out this row, we still need 3, 5, and 7. There's already a 3 down here in that row, so 3 must go up here. And really, the only way to get this answer of 2 would be 5 minus 3, leaving the 7 here. We have a 3 and a 5 left going here, but we don't know what order yet, but I'll put some notes in. Okay, we got 3 and 5 here, 4, 5, and 8. Let's take a look down here. 16 in this corner. We have already got 6 of it accounted for, leaving 10. 10 can only be accomplished 3 ways. 6 plus 4, 7 plus 3, or 8 plus 2. Because we already have a 6 and an 8 in that row, this must be 7 and 3. We don't know what order yet, but I'll put some notes in. Okay, our notes are in place. We are left with 2 vacant boxes that take either a 2 or a 4. That's all we know. But if we do put a 2 in here, to get this answer of 3, that would have to be a 5 there. 5 minus 2 being 3. We've already got a 5 accounted for, so 2 cannot go here. That means the 4 does go there. Notice when I put the 4 in, it canceled out the 4 down here. That becomes a 2. That becomes a 4. 4, leaving a product of 3, can either be accomplished 4 minus 1 or 7 minus 4. With the 1 in the row, that must be a 7. The 2 will finish out this row. Notice how that canceled out from the 1 and 2 combo there. The 1 will now go here. A 2 will go here. And in order to get this answer of 1, it's either 2 minus 1. Don't think that's going to happen, so that must be a 3 right there. Okay. Now, remember how we said there are no more 5s in either of these two rows. So 5 can't go here, a 5 can't go here. A 5 can't go in this 144 because it won't divide correctly, so the 5 must go there. Here's what we're left with, 1, 3, 6, and 8. We do not know what order, but we do know that the 1 cannot go in this particular triangular corner, because if it did, we'd be left with having to get 144 with just two numbers. That'd be 12 times 12, and it's an 8 by 8 puzzle. So all we know is a 1 is going to go up here. If there is a 1 up here, and there's a 1 over here, that means that this answer of 6 in the subtraction problem cannot be 7 minus 1, because we already have 1's accounted for in these rows. This must be 2 and 8. So let's put the 2 and the 8 in there as notes. Now notice that when we do that, if we put 2 and 8 in, it will cancel out the 2 over here. That'll become a 1. That'll become a 2. And then the 1 we were talking about here will go right there. Let me put the 2 and the 8 in as notes. When I put the 2 and the 8 in, we now know that this 8 will get canceled out. We are left with this row. We have some numbers we have to put in. We have to find a place for the 7. Now, 7 can't go here because there's already 1 down there. So the 7 must go in here, and the only way to get this answer of 3 is 7 minus 4. We don't know the order yet, but let's just put the 4 and the 7 in. And notice when we do so, it will cancel out the 4 here. But let me just put those notes in. Okay, like I said, the 4, 7 here cancels out the 4 here, so that becomes 5, which cancels out the 5 there, makes that a 3. This becomes a 5. We are left with just a 6 going here. 6 plus 1 is 7. To get to the 14, a 7 goes here. We are now left with 3 and 6 in these two boxes. Because there's already a 6 here, the 3 must go there, the 6 must go there. That 3 canceled out the 3 and that 3, 7 combo, so 7 goes there, 3 goes there. If we have the answer of 6 here, it can either be gotten by 7 and 1 or 2 and 8. Well, obviously with a 7 in the row, that must be 2 and 8. Don't know the order yet, but 2 and 8 will definitely cancel out the 8 down here. That'll become a 1. We know that's 2, 8, and we are left with, we know that's a 4. That becomes a 7. This becomes a 5. Let's finish out. Fill in that 8 there. Notice that it removed the 8 from up there in that 2, 8 combo, so that's a 2. Notice that when we put the 7 up here, it canceled out the 7 from this 3, 7, so that is a 3. This is a 7. This 7, if you carry it up here, 5 from 7 is 2, but we already have a 7 there, so this must be 5 minus 3. Take a look at this row. A 3 and an 8, we've already got a 3 here, 3 and an 8, finish that out. Now 8 into 144 is 18, divided by 3 leaves 6, so that must be a 6 there. That canceled out the 6-2 combo here, so that's 6. There's 2. We're now left with 1, 4, and 7 to complete that row. 1 can't go here. 1 can't go here because there's already 1 down there. So a 1 goes here. We are left with 7 and 8 in this particular column. Don't know the order just yet, but we do know if I put a 7 and an 8 in there, that this 8 will disappear, and that'll leave us with 4 there and 8 there. 7, 8. This becomes a 6. That becomes a 5. If we finish up this particular column, we have 6 and 4 left. There's already 6 here, so the 6 must go here. The 4 must go there. That canceled out that 4. 4, 7. Back over here for the 7 and 8. 7, 8. We knew this was 8 and 2. Now that there's an 8 there, we put an 8 here and a 2 here. We are left with 1 and 5. And in this particular row, we are left with 2 and 4. This already has a 2, so the 2 must go here. The 5 must go here. That cancels out the 5 down there. That's a 1. That's a 5. Here's a 1, and this is a 4 to complete the puzzle. And that's it.